Welcome to this episode of Tutoring 7th Grade Math. Today, I wanted to go over how to create an algorithm that will allow you to find the prime factors of a number. Okay, so we want to shortcut the process of getting to this factors list so you don't have to always do a factor tree, or this is also going to let you know if the number is prime or not. So if there's only one factor and that's itself, then you know that the number that you put in is prime. So here we go. Let's go ahead and get into the review of this algorithm. And we're using Python to set it up. Computer just kind of glitched out on me. I don't know what happened, but I hope you're still there. So anyway, the very first thing we see at the top is what's called a comment. I'm going to talk to you as if you don't know anything about Python, and if you do, bear with me. So the very first line of code in the middle here is the comment that says find the prime factors of a number. The next comment, so the hashtag in front of the sentence or phrase or whatever you want to make as a comment is what tells Python, hey, ignore this. This is not code. This is not something that you have to try to execute. Okay. And number 4 is the very first variable that we are going to what we call declare or set up. And basically it says this variable is called primes, and it's equal to this set of, or this list of numbers, 2, 3, 5, 7, 11, 13, and so on, are prime numbers. They're all prime numbers. And so the reason why we declare this variable is so that we have something to go by. It does limit us to what types of numbers we can put in to find the primes of, right? Because if we only have up to 97, then we can only do numbers that comprise of combinations of 97 or less, which gives us a whole lot of numbers to deal with. Don't feel like you're limited. You can always increase this primes list in order to have more primes at your disposal. Or you can also add an algorithm that allows you to add more primes as you go along. Okay, but anyway, I digress. This is a list, and notice that it's starting and ending with square brackets. Okay, so list defined in Python start and end with square brackets. That helps Python know where you're starting and when you're ending your list. And then every single entry is separated by commas. Okay, so it's pretty straightforward and makes sense. Now we're gonna go into the next variable, skip over line 5 and go to 6, and you'll see size is the next variable, and it equals to the len of, okay, so it glitched out on me again. I don't know what happened. I was sharing and hopefully it'll come up again. Right now I see a white screen. I do apologize for this. I don't know what's happening. See if I can cut this out of the video. But let's see. It might have something to do with the actual website that I'm on. So let me try again. Okay, so it might have to do with the website. So what I'm going to do is restart my web page. So the web page went out. So it's still recording. I'm still on. So I think I'm going to pause the recording real quick. Okay, so Microsoft Edge closed unexpectedly. let me just go back to the REPL. I'll share again. That might be the shortest thing. I do apologize for that. So let's try to share again. And if it does go out again, then I'll just go ahead and redo this video. All right. So we should be back on the screen. And the next thing we want to talk about is the line 6, size equals len of primes. So len, as you can see, is another color, right? Len means is short for length. Okay, and it's a built-in function inside of Python, and it returns the number of items in a container. So what container are we talking about? Well, we're talking about the primes container. So whatever's in parentheses is the container, or the very thing that we're trying to get the size of or the length of. That means how many are in the list. So we use len to find how many primes there are in the list, and then we assign it to size. Okay, I think I didn't even use the size, and we might be able to change up our code a little bit. So this is good. We can kind of spruce up our code while we're going through this code review. So this is awesome. Code review also allows you to see where you can make your code more efficient. So not that it doesn't work, it does work, but it could be more modularized, or something else could be improved on it so you can make better code. Anyway, I digress. Let's keep going. Line number 8 is another variable, but this is a unique variable in that it is a declaration of a list. But guess what? There's nothing in between these brackets. So that means the list is empty. Nothing in the list is empty. So we're starting out this list, boom, blank. So what's in it, and why do we want to do this? Well, basically we want to do it when we know that we're gonna eventually fill it, right? So right now it's empty, but we know it's gonna get filled up. New primes is going to be for new primes. If we discover that there's a new prime, then we can put it in this new primes here. All right. So I guess if we get to the end of our list, we got this number and we can't figure out the prime factors, or the prime factors is only itself, but it's not in the list of primes, then we can add it to the new primes. Sounds fair enough. Number 9, line 9 basically says, okay, facts. These are the facts, or the factors of the number that's being put in. So we're allowing just in case you didn't know, we're allowing the user of this program to enter in a number. And the factors of that number, the prime factors of that number, is going to be stored into this variable called facts. Okay, so we could have called it factors. That would have been fine too, but that's fine. I called it facts. So facts. Right now it's empty, but we want to fill it with all the prime factors that we find. So we're going to go through the algorithm to figure out, okay, let's see what factors we find. But I'm going to skip over this next function, function definition to find the product of given numbers. I'm not even going to worry about this because I don't use it, and I don't know why I left it in here. But the important function definition, a user-defined function starting on line 18, says I want to define the DEF. It is short for define. I want to define a function called find primes. So that means this function better find primes, right? So that's the purpose. So a lot of times when you give a name to a function that you are defining, make it make sense, right? Make it say what it's going to be doing. So a function basically is a set of code that's going to do something. You can call on it to do that set of something, repeatedly. So you can call it over and over and over again. And then we're going to be calling find primes over and over again for the number of times that the user puts in a new number. Okay, so let's go. In find primes, notice that there's a number in parentheses. Okay, if that parentheses was empty, that means I don't need any information. I can do what I need to do to find the primes without your input. But number is an input variable or a parameter that says, hey, I need some information before I can do what I need to do to find primes. Okay, so we're going to use that number. That number is required in order to find the primes of that number. Okay, so on lines 19, 20, and 21, we have 3 variables and we start them out with global. Global, this keyword global means, hey, I'm talking about something outside of myself. Outside of the definition of find primes, there are some variables that I might be using. So I put that global to say, hey, information that I need is out there somewhere. So that's where you need to get it, or that's where you need to refer to it. Since facts and primes and new primes are lists, then they're going to point to facts, primes, and new primes, these global variables. So that way, if you change anything about facts, primes, and new primes, it's going to be changed in that outside variable that we set up from the beginning when we're out, right before we started doing this definition. Okay, line 22 says factor equals number. Okay, so we want to take that number that was brought in and assign it to fact. So we have this new variable called factor, but this factor is only inside of find prime, so it's kind of local to that function. So the next thing we'll do on line 23 is we're going to start up a J variable. Now J is kind of random. It doesn't really mean anything, right? I could have gave it some name like index, because that's really what it is. It's going to be the index of the list, so we can keep track of where we are in the list of primes. And we start out with 0. All lists have an index or position number of 0. Always start at a position of 0, then 1, 2, 3, 4, and so on. Okay, so we declared this J variable, and the J, we use J just so it could be something short and quick to put in. I could put a note here, and that allows us to kind of know what this J means, right? Since I didn't make it a very descriptive name, it's probably best to put in a comment, right? What the heck is J, right? So it's the index of prime. All right. So then we go down to line 25. While factor is not equal to 1. So this is our stopping point. So we're in a loop. While is for a loop. And so we're going to be looping until factor is not equal to 1. So when we get to 1, when we get the factor turning into 1, then we know we're done. Okay, so that's the stopping condition. Factor equaling to 1. So as long as it's not equal to 1, we keep going. All right. So let's keep going. Line 26 is an if statement. The if statement says, hey, I want to know something. I want to make sure this is true before I do what's inside of the if statement. So the very first thing it says is if factor percent primes of J is equal to 0. So what in the world does that mean? This is the divisibility. Okay, so we're checking divisibility. Is it divisible by one of the primes? That's what we want to know. Okay, well, maybe I should put it up right above it so it doesn't carry over. divisibility. Divisibility. So what is divisibility? Can it be divided without a remainder? That's what divisibility means. It's just a big word that says, can you divide it by something and not get any leftovers, right? So boom, you can have equal sets of something, right? Okay, so that's what that percent means. Say I'm going to divide by primes of J, which is one of the elements in primes. And if it's divisible by one of the primes, guess what? That's one of the factors. Boom. So if the remainder, so that percent is really the remainder function. So if the remainder is 0, then it's divisible, right? And if it's divisible, then we're going to add that to facts. So on line 28, we say facts dot append primes of J. So we want to add that prime number to facts. That prime number is one of the ones that are divisible, that our number is divisible by. Okay, next, we talk about factor. What we're going to do now, we're going to change factor. We're going to decrease it to the other factor, the other factor that's has not been checked yet, right? So we found it divisible. And so the quotient of factors in prime J, right? You see how we're doing a division, factor divided by primes J. That is the other set of numbers for the other factor, of the one that is divisible by. So we need to check that. It might be composite. It might have some more prime factors in it. Otherwise, itself might be prime. So basically this is almost like a recursive step. We might be able to even use recursion if we wanted to, but that's a bigger picture, right? That's the coding design. We don't necessarily know. And I might have to pause the video. Give me 1 second, because my dogs are barking and I think I might be getting attacked. So give me 1 second. All right, let's finish up this code review. I want to continue by talking about, I think we left off at divisibility, and let's go right on into line 31, which is the else part of the if statement. So if it's not divisible, then we want to check to see, okay, have we reached the end of our list, our primes list? Because if so, that means we have no more to check. We got too far. And we don't want to check anymore. We just want to determine, what's what. If we have gotten to the end of our list, then we want to just set factor equal 1, which doesn't really matter. That's just kind of a fail safe, because line 36 says we're going to break out of this while loop if we've reached the end of our primes list and we haven't found a factor. Okay, so that means we're done and we don't have anything else left to be able to put into facts. And so we'll return facts, which is our list. If we keep on finding factors, it's going to keep on appending to facts. Otherwise, we either get to 1 or we get to the end of our primes list. So that's pretty much it for that find primes function. Okay, so we get to the end of our prime function, and this is pretty much the main code. All right, so I'll put a little note in here. This is the main code, right? And so you see it's indented all the way out here. The definition was indented right here. I mean, this is unindented, like this is the beginning of the line. And this is indented, meaning it's part of the function definition. Okay, so the main code is a for loop. And this just says, I'm going to run it 10 times, all right? Because it says 4K in range 10. So it says, I'm just going to loop through 10 times. And this, I put in a comment says, limit runs to 10 times. So we can find the factors of 10 numbers and boom, we're done. Otherwise, we could stop the code prematurely if we want to. Control C or, walk away from it. So either way, it doesn't matter. It just allows you to do more than one. But not keep on doing it over and over again. I could have added a stopping point. So say for instance, we want to keep on going, and we could have made it a while loop, and we could have stopped it when the user enters a negative number. So there's a lot of different ways that we could have went about controlling the flow of the main code. But this is what I chose to do. So line 42, number is equal to the input, right? We changed the input, which starts off as a string, but we convert it to an integer. See the int right after the equal sign? This turns it into an integer. Okay, so it converts the number or string to an integer. So that's what we're doing. So then we turn that and we assign it to number. And then we take that fact. Well, we take the find primes and then we assign it to facts. Okay, so facts was that original number to begin with. So now we're assigning to a function call because we're calling find primes function. And then we're putting in that number that was given by the user. All right, so once we're done with that, we'll just print out facts. Boom, and that's pretty much it. Well, at the very end, on line 45, since we're going to be going through this and looping again, we want to reset the variable for the next number. So that's why we redefine facts as an empty list. Okay, cool. All right, let's run this thing. We're gonna run it and see what happens. Okay, so it's telling me over here in the console area, enter a number. So I'm gonna enter a number. I'm gonna enter number 34. Okay. All right. Good number. It's the year that my daughter was born on my birthday. So boom, 34 is an awesome number. Let's see what kind of prime factors it has. All right, 2 and 17. So the prime factors are 2 and 17. So this is a game changer because guess what? I no longer have to memorize or remember a whole bunch of facts, right? I don't have to remember what the prime factors of a number are, but it's good to kind of know some of the prime factors. But in all actuality, we're in a day and age where we don't necessarily need to kind of memorize a whole lot of stuff if we have access to the information. If we know that the information is there, then we can just go to it. So this is that go-to type of code that allows you to check the prime factors of a number. Okay, let's do another example, 27. Another great number. You know why it's another great number? Not because all 3 of the factors are the same, which is a perfect cube, but because this is the year that I stick to. Every year when I turn another age, I just say I'm 27 again. But this is another great number. It was a great age. It was the year that I received Christ and the Holy Spirit, baptized in the Holy Spirit. Oh my gosh. So a lot of great things happened in this year of life for me. So let's do another number. Let's say we want 91. All right. You would think that 91 is prime, right? Like 91, like what 2 numbers or what numbers multiply and give you 91? Well, here you go. You don't have to remember it now. You can say, okay, 91 is 7 and 13. So now I know that it is not a prime number. Okay, let's try to figure out a prime number that there is. Okay, we know that that's on the list, right? That's definitely a prime number on the list. So when it says the prime factors are, if that number is the only number in the list, then we say that it is prime. Okay, so that's it. That is the whole disclosure of finding prime factors algorithm and showing the implementation of it and what it looks like. So if you ever need all the prime factors, which you will if you need greatest common factor, if you need to compare factors and see what's the least common multiple, if you need to know any of those things, having the prime factors list is going to be so beneficial. So in the next video or in videos to come, you will see the benefit of knowing the prime factors of a number. Thank you so much for listening in and bearing with me as I go through the details. Really and honestly, sometimes these calculators online, they don't go through the process of what it took to get to the output that they give you. They just give you something that you can use. Kind of like if somebody gives you a car, you don't need to know what's under the hood. You just start driving because you know how to drive, right? You don't know how to build a car, but I just showed you how to build a car. So awesome sauce. Thank you so much for watching, and we'll see you in the next one.